Okay, you've heard the terms thrown around everywhere, right? Machine learning, generative AI. They're pretty much taking over our world. But what's the actual difference between them? Honestly, there's a ton of confusion out there, and today we're going to cut right through all that noise. So, what's the deal? Are they like two rival tech companies battling it out for the top spot? Or is there, a deeper connection? The answer? Well, it might surprise you, and it's actually a lot simpler than you think. And look, we're not going to waste your time. We're going to unpack this whole thing in the next 5 minutes. No fluff, just what you need to know. So let's dive in. All right, let's just get straight to the point. The single most important thing to remember is this: generative AI isn't some competitor to machine learning. It's actually a super powerful, specialized part of it. Think of them as being in the same family. Here's a great way to picture it. Imagine artificial intelligence is this giant umbrella covering everything, okay? Under that umbrella, you've got machine learning, which is all about teaching computers to learn from data. And then, tucked right inside that is generative AI, the part that doesn't just learn, it actually creates. So to really get this, let's zoom in on the powerhouse that kind of started it all, machine learning. And I like to call it the predictor. The key word for machine learning, you got to remember, is predict. Instead of a human writing code for every single possibility, ML models learn from data to find patterns, and they use those patterns to guess what might happen next. Like spotting a spam email before it even lands in your inbox, or trying to predict how a stock will perform. It's all about analyzing what's happened to understand what's going to happen. And machine learning isn't just one thing. It has a whole toolkit for how it learns. Sometimes it learns from data that's already been labeled by humans, like a million pictures all tagged cat. Other times, it has to find hidden patterns all on its own in a huge mess of unorganized data. It can even learn from pure trial and error, kind of like an AI figuring out the perfect move in a chess game. And trust me, this isn't just theory. It is working behind the scenes in your life every single day. That fraud alert on your credit card, the product recommendations you see on Amazon, that's all machine learning, acting as the engine that makes all the smart predictions. Okay, so if machine learning is the predictor, then that brings us to its really powerful new sibling, generative AI, or as I like to call it, the creator. And this is where things get wild. The key verb here is create. Generative AI uses these super complex models, kind of inspired by the human brain, and trains them on just massive, massive data sets. And the result? It doesn't just analyze the data, it generates something completely new and original, whether that's text, an image, or even computer code. Renana Gupta from MIT Sloan really hit the nail on the head. She said machine learning finds the patterns, but generative AI uses those patterns as a jumping off point to create something that has literally never existed before. That huge leap from just finding to actually creating, that is the game changer. And the ways we can use it are just exploding. It can draft your emails for you, help developers write code way faster, and it can even create totally artificial data to train other AI models when the real world stuff is hard to get. It's a tool for creation and for speed. Now, you might think this whole thing just appeared overnight, but nope. This overnight sensation has been a long time coming. Let's take a really quick look at this 70-year journey that got us to this point. It all started way back in the 50s with AI that could only follow really rigid rules written by people. Then came the first big shift, machine learning, where systems could finally learn patterns from data themselves. The 2010s then supercharged all of this with deep learning, using much more complex brain-like networks. And that brings us to today and these foundation models, these enormous, do-everything AIs like GPT that are trained on basically the entire internet. Each step totally built on the one before it. Okay, so we've got the history, we know the difference, but how do you choose the right tool for the job? This is the really practical part. And first, let's just get a sense of the scale here. A recent survey found that 64% of top data leaders believe generative AI could be the most transformational technology of our generation. The potential is absolutely massive, but that doesn't mean it's the right choice for every single task. So here's a pretty simple guide. Think about using traditional machine learning when your goal is all about prediction and precision. It's perfect for things like fraud detection with sensitive data, or for really specialized technical problems. But if your goal is creation and communication, like brainstorming ideas, drafting an email, or generating an image, then generative AI is your go-to. It's built for creativity and just getting things done fast.
So, what's next? I mean, this technology is incredibly powerful, but it is far from perfect. Let's wrap up by looking at some of the big challenges that are still ahead.
These are the major hurdles we still need to figure out. You've got hallucinations, which is when an AI just confidently makes things up. There are huge security and privacy questions. The cost to train these giant models is astronomical. And finally, there's the black box problem. These systems are so complicated, we often have no idea why they came to a certain conclusion. Solving these issues is the critical work that's happening right now.
And this all leads to maybe the most important question of all. This technology isn't just predicting our world anymore, it's actively helping to create it. So as these models get more and more powerful, the line between what a human creates and what a machine creates is just going to keep getting blurrier. So what does that mean for creativity? And how do we navigate a world where a machine can be an author or an artist or a programmer? That's the future we're stepping into right now.